In this video, we're going to go through a sorting algorithm called Heap sort. We'll see how it works step by step and apply it to an example. By the end of the video, you will understand how to use heaps to sort data efficiently. So to get started, what is a heap sort? Heap sort is basically a sorting algorithm that uses a structure called a heap. And a heap itself is a complete binary tree which means that each level of the tree is filled from left to right. And there are two types of heaps. So we have a max heap and we have a min heap. We've already looked at this before, and you can refer to the previous video to understand those. But in a max heap, which is what we're using for heap sort, in a max heap, each parent node is greater than or equal to its child node, and the largest element is always the root. Right. So basically, that is how it works. And this is the array that we're going to try. This is the array that we're going to try and sort, and we're going to look at it step by step. We're going to use heap sort in this case. So we're going to build a max heap from the array that we have. And once we have a max heap, we're going to repeatedly remove the largest element and place it at the end of the array until the array is fully sorted. So what we have here at first, this is a binary tree representation of this array that we have here. Now, the first step that we've said that we're going to go through is converting this into a max heap. So to convert it into a max heap, it's going to look like something like this. What we have here, this is what it looks like when it is a max heap, right? So and how we try and arrive there is we just adjust the tree and make it a max heap. And basically, again, as you know, in a max heap, you have the largest element is going to be at the root, and that is what we have. So an array representation of this would look like something like this. So we're going to have 50, then we have 40, 30, 5, and 10, where the largest element is the root. And as we know, 50 is the largest element. The second step in our sorting process is going to be extracting the max element and sorting. So now we're going to remove the root that we have here, and this 50 that we have is the root. By the end of the array, rather, we're going to remove it and put it at the end of the array. So we're going to swap 50 with the last element. Then once we swapped 50 with the last element, what this array is going to look like, it's going to look something like this. So it's going to look like this. So we're going to have here, it's going to be 10, and at the end here is where we're going to have 50. So this is what we get. This is what we get. And then after getting this, now we heapify the remaining elements to make sure that they maintain basically the max heap structure. And if we do that, this is how such a tree is going to look like. So we're going to just get a copy of this. Once we heapify, how it's going to look like, you're going just to maintain the heap, the max heap property. 40 is going to be at the helm there. Here we're going to have it's okay. Let's just delete this. So how this is going to look like, we're going to have 10 here, and 30 is going to maintain as it is, and we're going to remove this 10 because we have swapped it to come up here. So our array now becomes something like this now. So how that array is going to look like is we're going to have 40, which is going to be at the top there. And then we're going to have 10. We're finally going to have 30, 5, and 50, where with the largest unsorted element, 40 in place. So 40 is the largest unsorted element that we have here. Now we're going to continue this process by swapping and heapifying until the element has been sorted. So by the end, we're going to have something that looks like this. So by the end, we're going to have the first element here is going to be 5. Then we're going to have 10, 30. Then here we're going to have 40 and 50 at the end, which is our sorted, which is our sorted array. Just to repeat this process again, how we do it is first, we're going to basically begin with the array that we have, which is here, and this is how we organize it in a tree. So in a binary tree representation, then we convert it to a max heap, and this is the max heap that we have. Once we have converted this binary tree representation that we have here, once our max heap is ready, it's going to look like this. So we have 50, 40, 30, 5, and 10, which is our largest element at the root, 50 now, so that maintains the heap structure. Then the next step from there, we're going to go and extract the max element and basically sort. So we're going to move 50 to the end of the array, and we're going to swap 50 with the last element. The last element is 10 and 50, so we swap them. 10 is going to be the first here, 50 here. Then after doing this, we're going to heapify the remaining elements. We still want to maintain the max heap structure. And this is what that max heap structure is going to look like. And after that, our array is going to look like this. So we're going to, where we are going to have 40, which is the largest unsorted element in place. And we're going to repeat that process over and over again until the entire array is sorted. So what we're going to have here at the end, this here, this is the sorted, this is the sorted array. So we're going to have that as the sorted array, like that. And that is basically how heap sort works. Just to go over it again, we build a max heap from the array. We extract the largest element. We move it to the end. And then we're going to reheapify the rest of the elements until all the elements are sorted. The heap sort method here is algorithm is going to be efficient, and it's going to run in O of n log n time. So it's going to run in, let's make this a bit larger. Okay, it's going to run in, okay, let me just move it somewhere here. It's going to run in O n log n time. So O n log n time. And basically we're going to making this rather the running time makes it efficient for large data sets, as you can see here. And yeah, that's it about heap sort, and I hope you're able to get some value from this and how this gets applied. Thank you, and I'll see you in the next one.